everyone. So today I'm going to show you how I created recreated this Pascal marble run. That is a simple physics experiment just to show how if you set up things like in this screen the correct way, you end up with a Gaussian curve. So if you're interested in seeing how it was made, let's go, come with me. Well, first of all, it's a very simple scene, and I not used anything except the full elements. The only exception is this package, the all-in-one sprite shader, but it was just to make the circle more beautiful with these shadows and gradients inside. But despite this, all we have here is a setup with our main camera with a higher size, so we can show everything in one take. Our global light 2D, by the way, this is a Unity 2021.2 project with URP already set it up, and post-processing volumes, just a game object called post-processing with a volume, global volume, and some bloom, just so I can also make some things glow. This is a game object to separate other game objects. And in our environment, we have this background that is just a rectangle. In order to properly apply shaders to my shapes, I've recreated a rectangle and a circle in Affinity Photo, but this rectangle is simply a gradient that I've done via this all-in-one shader that I talked about, with the bottom color and top color like this. The cage is simply a bunch of rectangles. The floor, the wall, all of them with their respective box colliders, just so balls won't fall through them. The obstacles are all these circles, and the only thing that I suggest you to do here, despite adding the collider here, is to create this physics collider that I put inside my materials. It's simply a collider with a little bit of friction and no bounciness, so I won't have balls colliding with balls and going down here more often than they should be. And those balls, I try to make them as symmetrical as possible. What do I mean by this? Is that if this one is on 0.7, this one should be at minus 0.7. I also noted that this one's a little bit offset in the y-axis, minus 0. Alright. And I've done this for all the rows in all balls, just always the symmetrical as symmetrical possible. The values here, y is 0.7, was just done empirically. I've just tweaked the values until I got a value that had my balls dropping in the middle of these bigger balls. The obstacles are all those circles here. You can see that if I toggle it on and off, they disappear. Let me select all of them. They disappear. The spawn point is the point where I'll make my balls appear when we play. I put this hamburger tag here just so I could see it better. The boss transformers are those areas here where I've put some containers. There are simply colliders with a top left and a bottom right area, so I can later check for colliders inside them. It was done kind of manually, so there's a little bit of room for error here, but you can just tweak it as you like it, so you can have it better. And for the other ones, I was simply just adding numbers, like 1.7 here, and having my numbers for the other colliders. Those are the boss transformers. And finally, I created two blockers here, just so when I spawn my balls, they don't fall off to the sides, because I'm going to be spawning them in a little range over here. That's my environment over here. And my managers, they are kind of the brain of this operation. It's just a simple game manager. And now let's look at the logic behind everything, just so we can understand what's going on here. We have simply two scripts over here, the balls transformer and the game manager. The game manager, let's open it. The game manager simply receives three variables: the game object of the ball that we are going to be instantiating, the amount to spawn, and the spawn point that we saw earlier. In the start function, we start a coroutine that will spawn balls. We check for a total spawned, and while we don't reach the total, we are just increasing them, instantiating them in this range between 0.05 negative to 0.05 positive in the position, the y position of the spawn point, and 0 in the z-axis because we don't care about it. Quaternion identity, just so it doesn't have any rotation when it starts, and instantiating the position. And we wait 0.1 seconds for a new ball to spawn, because if we waited lower than this, we would start to get a lot of balls in the same place and it would interfere with our experiment. So that's what this manager does. If we go back to Unity, we can see that we are inputting this ball prefab that we created. That again is just a simple ball with the colliders 2D, the same physics material here, just a shader just so it can glow a little bit like this. We'll see this in action. And the big ball, why is the big ball here? Well, it was simply because when I was first trying this, and trying with a lot of balls, like 1,500, 2,000, my computer started slowing down a little bit, so I just had this script over here that every transformer has. That is the ball transformer that receives the big ball, and it's not the best logic ever, but let me open it. It simply waits for someone to enter his trigger collision, and if it's not the someone that entered isn't a ball, it just returns. But if it is, he takes the overlap area of everything he can find between this area, that hence the top left and bottom right corners. And if this length is divisible by 5, and it leaves a little bit of room for error, but I just wanted to encapsulate small balls into bigger balls, so just so I could delete some balls in the scene. But after 5 new stuff enter the area, for every ball collider, I destroy the small balls and create one big ball, and that's simply it. And if we look at everything together, and that's really all there is, we are going to see that after 1 minute or so, we are going to have close to a Gaussian curve here, and I think that's beautiful. Let's just see it in action. Let's go. That's it. The balls are falling. That's nice to see. You can see that when they fall and we have more than 5 over here, I spawn balls in the center of those areas, of those containers. And if we wait a little bit, we're going to see that both of those two are going to be filled. Those two are going to be like half full, and those two are going to be like just one row full. And it's very beautiful. It's like snow falling from the sky, you know? It's like, yeah, it's beautiful. That's pretty much it. If you liked this video, give a thumbs up. It helps a lot. I'm going to be back with a lot of projects now orbiting around Unity. It has got a little bit better over the last few months, so I'm going to give it a try again. And let me know if this was useful for you in the commentaries below. And if you like some different videos about game developments at all and other topics like game design and marketing for game development, consider subscribing, because there's going to be more and more for you regarding those topics, okay? And that's it, my friends. See you soon.